Okay, this Lewis structure video will deal with the concept of resonance, which hopefully you remember from your honors chem class. So before I talk about resonance specifically, let's combine a couple of things. Let's draw let's see, I think, will a carbonate anion have resonance? Yeah, let's find out. Okay, so you have to remember how to draw Lewis structures of polyatomic ions. This is the carbonate anion. So our need number is going to just be like any other need number. Everything here is following the octet rule. So I've got 1 carbon, 3 oxygens, 4 atoms total. 4 times 8 is 32. I hope. My available number, let's see, I've got 3 oxygens. They have 6 electrons each. I have 1 carbon that's 4. So 3 times 6 is 18, plus 4 is 22, plus 2 more electrons. The -2 charge means I've got 2 extra electrons. That's only going to affect the available number, not the need number. So 3 times 6 is 18, plus 4 is 22, plus 2 more is 24. And then I am going to have to share 8. And I'm going to have 24 minus 8, 16 left over. That will give me 4 bonds, and that will give me, oh, that was a mistake right there, hold on. That should be divided by 2. So I'm going to get 4 bonds, and I'm going to have 8 lone pairs. Okay, now let me erase a little stuff up here, and let's try to draw the carbonate anion based on the nasal we just did. Okay, so I am going to, as always, put the guy I have one of in the middle and surround it with the other, CO3, so 3 oxygens around the carbon. Don't worry about the shape right now. Okay, nasal gives me 4 bonds. Remember, nasal is giving me 4 lines here, not necessarily bonds per se. And so I have 3 places to put them. That means somebody has to be a double. I'm randomly going to select this top one right here to get the double. The other oxygens are getting the single. Okay, I've got 8 lone pairs. Wait to distribute the lone pairs after you have set the location of the single and double bonds, because that will determine who needs how many lone pairs. The oxygen with the double bond needs 2. So that's 2, 4, 6, 8 around that oxygen. The carbon is good. He has a double, that's 4, and 2 singles, 2, 4, so a total of 8 electrons around the carbon. The other 2 oxygens, the ones with the single bonds, have 2 electrons from the single bonds, 4, 6, 8, 4, 6, 8. Okay, so there is the carbonate. Remember, when you're drawing a polyatomic structure, convention says we put it in square brackets, pretend those are square brackets, and put the charge up top on the upper right. Now, because I've got more than one place that double bond could go, because I had to randomly pick where I would put that double bond, and there's only, there's 3 possible spots for it, I now have to draw resonance for this guy. I am representing that double bond is not really locked into that one location. Instead, it really is in all 3 spots at once. We talk about this a little bit more as we go forward, but for right now, we're just going to talk about it the way we did last year, which is we represent the resonance like this. We draw 3 equal structures, and we move the lone pairs and the bonds around to every possible of those 3. We'll get rid of that, of those 3 locations. So this is my 3rd final structure. That's a single. He gets 3 lone pairs. This single gets 3 lone pairs. That guy only gets 2. Once again, pretend, that is a square bracket. and there's the 2 minus. Okay, so in this video, we talked about drawing Lewis structures for polyatomic ions and showing resonance. Remember, the -2 for the carbonate anion meant that we have 2 extra electrons. So our available number was 2 higher than we would get just from adding up the valence electrons of 1 carbon and 3 oxygens. And it's 2 more because, of course, electrons are negative. If we had a positive cation, like let's say the ammonium cation, our available number would be less. The positive charge means, positive 1 charge here means we have 1 less electron than we would expect. Okay, thanks guys.